Hi, my name is Rocky. Welcome to the AGI House. So this summit is about one question, and what happens when AI started doing research itself? So our next guest is speculating about that future. Isn't speculating about that future. He's betting his company on it. He spent 7 years at OpenAI. Well, he led the team that taught the language model to think, O1, O3, and the reasoning inside GPT-5. Before that, he was a primary contributor to Codex, the model behind the GitHub Copilot. And before any of that, he taught a robot hand to solve a Rubik cube. In January, he walked away from one of the most powerful research posts in AI. And in April, he launched the core automation with the explicit goal of building the world's most automated AI lab. Please welcome Jerry Tworek.
Thank you very much. Thank you for inviting me. I'm happy to be here.
Absolutely. So we'll just get quite straight into it. It's like a technical peer conversation. So it's allowed to hear a lot of your takes on the state of the art of AI. So you spent 5 years at a quant in Amsterdam, extracting signals from noisy future markets. What did trading teach you about the most ML researchers never learn? I think that's the first question.
That's a great question, and I think there are some skills and there are some necessary bits that transfer. What mostly that trading has taught me about machine learning research is about being paranoid about your algorithm and finding bugs. When you are implementing a trading algorithm, slightly similar like ML, you are building code that manages a whole bunch of numbers, and depending on like where you get good output, good input, you have good output. But if something gets wrong, what usually you just get a wrong number in the end. And that number may mean you buy instead of sell or do something wrong with large sums of money. So being a good trader means having to understand your algorithm very well and knowing whether it works well, whether it is doing what you intended it to do or not. Because in the end, what you see, the output is just P&L. And the first thing when I started doing AI research, I was very paranoid about everything that happened inside of a network, of a learning algorithm, of hyperparameters. And I was always double and triple checking everything to make sure I know what is going on and making sure that the algorithm is doing exactly what I want to be doing, because previously my algorithms were trading large sums of money. And that is a superpower in many ways to doing AI research very well. This is one thing that I would recommend every researchers that are becoming researchers in the current times of AI research being largely automated, and technically models can do a lot of your, but there's no way to outsource your understanding. So it's good to know what is inside of the box.
I see. Yeah. Coincidentally, we actually observed a lot of the great researchers come from the trading background. If you remember the company DeepSeek, I think the whole company was around there, and now they are doing that. I remember last time we have this AGI dinner series. So one of the co-leader of Google Gemini, Oriel Vinet, he was here. We're talking about actually one of our guests asked the question. He was also doing trading backgrounds. Like they have clear objectives, maximize the return. Yes. Does that create this kind of right RL environment for researchers to do the experiments, do the research?
Yeah. I think trading is a great RL environment, and there are obviously there's no perfect environment in the world. Every environment has its upsides and downsides. For trading, it is like relatively small signal to noise, which together with sample inefficiency of RL does create some amount of challenges. And another one is that feedback is not often very quick. Sometimes you have to wait a little bit, but beyond that, I think some people are already very successful at applying reinforcement learning to research. This was in some way the decision I have made in 2018. Do I want to go in the AI lab and try to apply the AI for programming, for doing research, or do I want to apply reinforcement learning to trading? I decided to join an AI lab. I probably would have been one of the early people to doing reinforcement learning in trading, but it does seem to be a very successful field right now with the current state of technology.
Yeah, absolutely. We've seen that. So once you said you're a mathematician at heart, and where does the mathematical taste actually show up in the frontier research nowadays?
A lot of it is thinking from the first principles. In some way, mathematics is the language of abstraction, and a lot of how, at least like how human mathematics works, because I think when the models will take over the field, and will probably happen pretty soon, mathematics will very differ, and the models have the ability to operate much more objects in their head and much more objects in their attention span. But what human mathematicians do, they essentially build towers of abstractions to be able to talk about complex objects relatively easily for them, and everything has to be, as you know, in mathematics, completely formal. Everything has to be tight, and all arguments have to like be checkable and verifiable, follow the rules of logic. And mathematics is about constructing how do you follow the rules of logic to construct more and more abstract objects. And in some way, it allows you to have a good bird's eye view on machine learning research. What are we actually computing? How are we computing it? If you can build a good abstraction around it and start manipulating this abstraction, I think it's a very powerful field to start understanding why our models can do certain things, why they cannot do certain things, what are the actually loops, what are the inputs, what are their outputs. Like all those things are in some way mathematical objects that we can keep manipulating and building understanding of.
Cool. Yeah, that goes back to the root. Math is still very, very useful on this. Well, we're going to the core, one of the things that you did at OpenAI. So you started OpenAI research into training LLMs on code. And when there's a primary contributor, you're the primary contributor to the Codex. Why was code the first verticals that you are working on? Was it the data, the verifiability, or something else that you see at that time? Yeah.
Great question. And in some way, though, it seems to have been a very good decision back in the
day.
day.
Yeah, 21.
But like my take was, you have to understand where the field was at that moment. It was a moment that GPT-2 was trained and already presented to the world, but there was this whole narrative of GPT-2 being too powerful to release, and people being worried about it. Today's open weight models are like thousands, millions of times more powerful than GPT-2, but it was at least worthy discussion to have. But what GPT-2, if you look at that model, what it could write a few coherent sentences, and that was about it. What the limits of it were. Then internally, the OpenAI started seeing GPT-3 and what it could do, and well, lo and behold, it could do few-shot prompting, and another technique that at that moment felt kind of groundbreaking, but at the same time, from today's perspective, it is not that much. And I was, in some way, there was one trend at OpenAI at that moment of excitement of new technological development and models being able to do something that we couldn't do before. But I had this inherent belief that those models are very vague. When they generate a few sentences, how do we know if those sentences make sense? If the model is actually smart? Where are the models stochastic parrots? Do they just regurgitate the training data? They are trained on everything in the world, and everyone tries to put as much training data as possible. And then the model writes for you a few sentences, and you don't know if you really have hit some interesting like thoughts, if the model came up with something, if it just came through the data. So the way of like teaching models and evaluating models for writing programs, we kind of started firstly with measuring even what do we have. Our first paper is I think called Evaluating Large Language Models for Writing Code. It came from perspective of like we have to understand if they can reason and if they can come up with interesting programs. And then I think verifiability was the part of pinning down the model if they actually understand what they are doing, because in some way you cannot write a correct program if you don't understand the concepts. Like it's always easy to talk around in various hyperboles or around the topic, but it's very hard to write a program that is true. So I think that was the main thing. And looking at various scaling laws, already then we started looking at things like test time compute and how does that scale, how does size of a model scale with understanding. How we were able to generate a whole set of problems that were kind of out of distribution. Pretty sure no one thought of something like that before, and measure how those things do. And I think from that perspective, at least to me, a lot of my understanding of how large language models think and solve problems came from that time and that era.
Yeah, so we still remember here. So that's a company called the Cursor was built on right on that. I think it's the end of 2023. So we host a hackathon here with some of our people who host hackathon discovered that, and we at that time we know like coding is still a very toy kind of application. So, people suspecting is it working or not kind of situation. So you guys are already doing that 2 years ahead, made that work. Yeah.
We're ahead of all of the things. Like the world doesn't see the things that OpenAI is working until it comes out. But yeah, some of those things we started.
Yeah. So go back to the question about the HumanEval. I think that one of the things that gives the field that a functional correctness benchmark. How much of the last 5 years of progress is downstream of having the verifying like reward? What do you think?
Yeah. I think. In my mind, and I will be like a little bit spicy, but I think the era of evals is done.
It's done. Okay.
I think the evals don't make sense anymore, but they did matter for quite a while.
Yeah.
For a while they were the main driver of progress, partially because they weren't yet gamed super hard, and partially the models were not very good at eval-like problems.
Yeah.
Like HumanEval, what literally me and Wojciech Zaremba, we sat in the room and hand rolled like 30 problems each first. Like I just wanted to see how the models would do on a problem like this, and it was part of our experimentation, part of our understanding. And then we saw better and better models, better and better reasoning techniques could keep improving those models. And I think there was a golden era of HumanEvals for a year or two, or maybe even 3. Hard for me to say exactly. But with the reasoning models today, and especially like with RL already at its height, and everyone building environments to almost whatever they want, and the training frameworks that allow you to spend a lot of amount of compute on pretty good base models, like almost any task that you want, you can put into the model. Almost every eval gets gained immediately. Like you look at the model benchmarks, and like sometimes when a benchmark is published, it has 50%. That's probably the lowest the benchmark has these days, and shoots to 90 with like 2 or 3 model generations. Like we live in the world that whatever benchmark you have, you'll max it. Like there's an algorithm, there's a loop for it, and you can just do it. So I don't think realistically the evals are the right way to look at models anymore. We need to look at it models from a continuous process perspective. Eval is like a single point in time. Does a this model do? But like the question is a lot about the improvement of the models now. How does the model do from like today to tomorrow to the next month? Because we know that the models are not doing everything for us yet, but they are kind of growing, and this direction of growth is also like steered by people in the labs who are trying to think what people want the most and where do we direct our attention. But like no individual eval like right now kind of like can tell you a good story about that. Mostly how much like this particular eval was in the mind of people training the model.
Absolutely, I mean, totally agree. But right now, like continual learning, like you need the model should be improve itself is the next frontier, right? But then the thing comes back to like, how do you know the model is improving? You still need some kind of verification mechanism, eval mechanism, right? So how do you see that, right?
How I see it, and it's a great question. It comes back to trading again, which is how do you evaluate trading algorithms? And there's always you do backtest, and then you do real world test. Both of those things are necessary to really validate algorithm. How does backtest work? You choose a date in the past, you train a model on all data from the past, and then you test it on like a new fresh data that the model has never seen through training. And that is in many ways the best way to measure if your model like has some ability to generalize to the new data, new time, and this causality and this arrow of time is very, very important in that respect. And I think in the same way, when working with LLMs, we need to be able to like have some data from the past, and then try to figure out how do we do how do we adapt to data from the future, that there may be some distribution shift, there may be some differences. When doing trading, you have to be very careful to not leak any information about the future in your training data at all. Every trader has made this mistake, that was thinking, oh, I have a good algorithm, and then you realize you are leaking future information somehow, and some of those can be very, very weird and very, very, very difficult to predict. And then there comes the real world test, where you actually train the model on all your data, you deploy it in the real world, and then how you see how the model does in the future, how does the model does tomorrow. So like the kind of the process evaluation to me is like you actually deploy the model in real world scenarios, and then you see like you could do like live A/B tests, this model or that model, which one does better, like tomorrow this model or that model, which one climbs faster. The only test is the real world, and the only actual measurement is using those models for automating work.
Having the real world feedback. Yeah, cool. So next question is like Copilot was arguably the first mass market LLM product. So what did this deployment teach you that benchmark couldn't do in terms of the real world feedback?
I think there's a main answer which is very real and very, very kind of boring, is that real world and evals are not the same. You can have a lot of the evals, but whenever you deploy product, you start realizing there are ways to improve the eval that don't improve the product, and there are ways to improve the product that don't measure in the eval. There were a lot of things that we did that were improving the model. We were shipping them to Microsoft, and Microsoft like, our users that don't care about that. So whenever you actually want to provide usefulness to the world, you need to like start thinking, how do I measure that usefulness, and how do I make sure we are building like the models that people need, which is like, latency, performance, like speed, depth of reasoning, the type of use cases. It was like very quickly we started doing things like harness engineering, because you kind of realize that training models is slow, and a lot of things you can build around it, and you can do harness to make better GitHub Copilot, and like those things compound in many ways.
Absolutely. Yeah, we do agree. Actually, I was hosting Sergey here last month. We have a very interesting conversation about how Google is training the coding agent. He asked this question: are those like GitHub's the code and GitHub's the right training data? He was asking. I asked him, did you train all the Google code base? He didn't have the answer yet.
Everyone is worried of
training. Exactly. So we'll go to the next question. Is about your 2021 verifier paper on mass world problems. Now it looks like the seed of test time compute. So you've done so many groundbreaking work on those things. Walk us through the intellectual leap from train a verifier to rank samples to run RL directly on the chain of thought. So what actually happens inside the O1 when it thinks? I think that's something they're very curious. We see the traits, but I think we'd love to see from the first principle how you have the intellectual things like that make this work.
Yeah. Like the dream of scaling RL was with us for a very long time at OpenAI. I joined OpenAI because I wanted to work on reinforcement learning, and one of the very first research all hands that I came, Ilya Sutskever stood on stage and said, our research roadmap is to train large generative model and then do reinforcement learning with it, which was like extremely precise. This is exactly what we are doing today, 7 years later, and he saw it, and he knew that this is the plan. But we didn't at that moment, we didn't know what generative model we are training. How do we do reinforcement learning? What is the algorithm? Like PPO was all the rage at that moment, and we were doing a whole lot of PPO, mostly on data and robotics. Like it took us a while to get there. Mostly like a lot of that was about the algorithm, and some of it was a bit about conviction. Like a lot of times we wanted to scale up RL, but there's always this problem: where do you get GPUs from? How much GPUs do you allocate? And the discussions with OpenAI leadership a lot of times were, give us some proof that makes sure that we actually it is worth, because we could be training like GPT-4, GPT-5 on those GPUs. Why would we scale RL? Like I was RL pilled, but there are not that many people at OpenAI were RL pilled. There were naturally some of us, but I think for many years it was minority. And there was always this chicken and egg, like how do we make a proof without having a GPUs, but you need to like catch 22 kind of algorithm, kind of problem. And I think a lot on on actually the birth of scaling of reinforcement learning was the day when Jakub came to me and said, Jerry, hey, we want to allocate GPUs for scaling up reinforcement learning, like take what we have so far and start scaling it. I hope this will work out. And I think this became a self-fulfilling prophecy. We had the GPUs, so now I started to figure out, okay, how do we organize? We need to scale RL, so we need more data. We need to get problems. We need to an algorithm that scales. What has a chance of scaling? We need to set up like babysitting rotation and a people structure to make sure we can execute big RL runs, which no one has done before. And I kind of like, as I assumed success, started putting everything in place, and like things started like clicking and things started happening. It was a lot of progress in research as you assume. Okay, what do I need to get there, and then it all comes together. But like everyone already today like roughly knows the formula from a high level, which is like, you know, the idea that you need a reward for the environment is not particularly new. Like rewards in RL have been for a long time, but a lot of the difficulties is like one thing. This simple idea of you do multiple rollouts for a single prompt to build a baseline is a really powerful one, and that helps a lot. There's a lot about numerical stability. There is a lot about like, you know, some things had to be removed from PPO to make the algorithm work better and scale better. There is always this notion that simplicity is what makes scaling work. Your algorithm needs to be simple. So like, you know, today's like set of algorithms for scaling are actually that simple in multiple ways, but this is what I was able to get to scale.
Great. So when the model backtracks and say, hey, wait, let me reconsider, is that emergent from RL, or do you think it's shaped by the reward design?
Completely shaped by
RL.
No, like the rewards have nothing to do with it, and the model just figures out, and it's very quickly that you know it is what helps it think longer. In some way, what is happening in reinforcement learning is that the model takes all the behaviors and all the types of activation that we'll learn through pre-training. It sees all the texts and all the bits where someone was thinking, someone said, hey, let me reconsider this, tries to recall those things and use it almost like a function call with a chain of thought to steer its reasoning, and then those that are more successful get reinforced.
Got it, I see. So you described the O1 as essentially a tech demo that was great at puzzles. Yes. And O3 as a tool use shift. What changed in training to make tool calls part of the reasoning loop?
Yeah. It's like 99% about systems and 1% about algorithms. We had a few interesting algorithmic problems, but a lot about doing tool use at scale. It's just very hard software engineering problem. Every lab and every company doing it right now knows how painful it is. It's at some moment you are operating distributed system that is the size of the largest distributed systems ever built. I think like our OpenAI training framework had more virtual machines, had more data moving than like Netflix, Amazon, like imagine whatever, like Facebook, very likely, like imagine any big website that people were thinking, oh, this is scale, this is what we are scaling, and our team had to build it in a few months to train models. And then we're pushing a lot of data. There was a lot of synchronization, a lot of trying to make sure that we don't hit bottlenecks of scale, and a lot of trying to shard things, and all trying to communicate things. That's the main problem that we did. We know that when we do that, it will work because the reasoning already worked. Mm-hmm. We knew that things like programming do require that, and that feedback from the real world will be very useful, but the engineering part there was brutal.
Yeah, I was always thinking it's like the tool is more like an architect. You're trying to conduct whatever tools to use for the specific problems. Yeah. So the follow-up question is like, what does extra test time compute stop paying? When does like extra test time compute stop paying? What does that scaling curve for thinking time actually look like across like different task types?
Yeah. Like we haven't seen any meaningful limits to test and compute. The limits are twofold. But I think the biggest limit is just latency. Doing very long rollouts take a long time. Not that many people want to wait that long time for very long rollouts. That's a pretty big deal. If you, for example, in your training, start having rollouts that take a day of time, you know, it very much limits how many steps you can take, what you can do. There are only so many days in a year, so that's a pretty big limiting factor of how long of rollouts you can take. And like second thing is a bit more architectural. It is obvious, but transformers, like their generalization with longer and longer context is not perfect. It is slightly difficult. So both of those things make this slightly like hairy and gnarly problem. We just don't have very long rollouts because no one wants to wait for them, and it's hard to iterate on very long rollouts because they take time. I think like we already see currently the trend of people doing like more parallel rollouts, which are called sub-agents. That kind of clears the latency, but it's also much less useful. It's not serial computation. Like the usage of those tokens is much worse. Those are more expensive. Usage happens. People complain that Cloud or Codex ate all our usage because it spawned those sub agents and they weren't that useful. It's a hard problem. It could be architectural. It could be RL problem in many ways, but we don't see as much progress here as we would like, largely because those reasons and limitations. But the models they kind of can generalize very far. Yeah. It's hard to optimize it.
Got it. So for GPT-5, they merged the reasoning and non-reasoning into one systems. And from a research management perspective, what was harder? Is it the science or the shipping a unified model into a billion users while the paradigm is still moving? How would you think about that?
It was largely an organizational problem, and it's some of it is innovator's dilemma, which hit OpenAI very hard around that moment. Which OpenAI had one of the most successful consumer product ever, ChatGPT, which had a very specific form factor of. We want models that respond very quickly with a pretty reasonable answer to a pretty small and easy problem. Yeah. And like there's a huge market in that, and there's just a really good product. And a lot of the early discussions was, okay, we have this model, it is a reasoning model, it thinks for longer. Technically, it is smarter, and we have this product called ChatGPT, and I guess it was trying to fit like a triangle peg in a square hole for a while. Which, like, you know, I think in many ways it was a good idea to bring them closer together in a seamless fashion. But ChatGPT, like, wasn't the right thing, and we only see right now it played out. It took World and took OpenAI to figure out that Cloud Code was maybe one of the first good agentic product actually, while OpenAI was trying to shoehorn agentic models into ChatGPT, and that didn't make any sense product wise. So like right now ChatGPT is reinventing itself into an agentic product because like it is clear this is a much bigger thing, and that the question and answer bot was a good thing, but at this moment it becomes like almost a smaller market of the AI landscape. So kind of like it was the question was, how do we use reasoning models to bring the most utility, and it didn't have the product form factor fully nailed down yet, and it shows only how important it is to innovate not only on the machine learning aspect, on the models aspect, but also how do we like get that usefulness into the hands of the makers.
Yeah, I see. So we switch a little bit out of the reasoning part of things. So that's a fun question. You are going to so we're talking about continual learning. Is it necessary for AGI? So you're at AGI House. So guests always ask this question. Yeah. So today's model becomes hopeless when they get stuck. Well, the human would learn from the failures and then come back stronger, I think. Why can't a bigger context window, better memory scaffolds, like can fake that? Like, do we need like a new architecture? I guess that's what we're talking about, right? And
that's what I believe. Yes, like the story is pretty the answer is pretty quick. Like if it would be enough, we would already have it. We have context that is like pretty long, at least in many ways. We have like we have all the markdown files and we have all the search methods, and does it work? I've talked to a lot of people who like have a lot of markdown files and are searching for them a lot, and everyone says it's brittle, it doesn't generalize, it doesn't work. But what it kind of reminds me is people trying to build agents in 2023. Remember AutoGPT or LangChain? Those were people saying, let's take GPT-4, it's a pretty smart model, and let's build agent on top of it by building scaffolding and harnesses and function calls. And in the end, it was a model issue. The model was not trained end-to-end to be a good agent. And right now we are thinking, the model has so much context, and we can do so many markdown files. Why can't we use that for learning? And the model is not optimized end-to-end for learning. I think those are machine learning problems, not markdown file problems.
Got it. I guess, is it right to say that you believe in this so much that you are, okay, I want to build a company around it. That leads you to the building of a core automation, yeah?
Yes. Whatever the expression is, I'm putting things where they need to be because I decided to start a company around that thesis and that idea.
Got it. So I think let's make automating research concrete. So I guess that's one of the missions of a core automation. Today at a core automation, what does an agent actually do when a research engineer did at OpenAI 2 years ago, like writing experiment code, running like elevations, reading results, or proposing like a next hypothesis? Or
we're trying to build an AI lab automation first, which is the idea is every work that we are trying to do first. The question is how do we make agent do it? How do we make AI? You need to have every time you start a research program, you need to have a baseline. And baseline is try to use existing agents for everything we do at the company and see how good they are. And then starts the process of what we think of and what essentially want to do with test time training. You build an eval, which is your lab, and the model does everything. And how do we improve that? How do we make it next day a little bit better? How do we make it next day better? And like that's that iteration, and that's that kind of like optimization on the thing that you actually care about. If your lab operation is what you want to make faster, this is what you optimize. No improving evals that you don't care about, that they're not your product, but actually the thing that you want to do. And as it gets better and better, I hope we'll become better and better company.
Yeah, absolutely. We're looking forward to that. What you guys come out of next. So there's some speculation that I guess reports describe a flagship concept called Cirrus. I don't know whether I pronounce it right. It's a model that keeps learning in production, updating weights from real-world experience, targeting something like 100x less training data. Wow. Without asking you to confirm like any code names, anything, how do you make a model that changes every day, safe and very evaluable and debuggable? I think that's like the next challenges, right? To do what we aspire to do.
Yeah. Like, debuggability is hard. I don't think I am very much like bullish about things like mechanistic interpretability. I don't think you can interpret humans and their thinking. Models have trillion parameters. Why would we think we can even try to grasp them and try to understand them? But we can definitely see and measure their behaviors. That is kind of like I very much treat models behaviorally. The models are their behavior and what they do in the real world, and I want to build a lot of I want to treat models almost like rats in a maze where we analyze everything they are doing and try to catalog it and try to decompose it and try to understand where is it getting stuck, where it needs to improve. You need to build a system like almost you think of you have an Olympic swimmer, the model as your Olympic swimmer, you want it to become the best of research, and you have to analyze like every minute of its life. What is it eating? What is its technique? At which moment it is like utilizing energy efficiently, at which moment it does not, and try to give it feedback, try to make it improve to become the best version of itself.
Great. So I guess like we come back to the question about architecture. I guess you're also exploring architecture that scales better than transformers. So what's actually wrong with the transformer for the future that you are describing? Is it attention cost, static weight, or separation of training from inference, or all of the above?
So the main thing which comes to what we talked before is we want to do test time training, and I don't think transformers are capable of test time training in a way that I want to do it. Transformer is a really great model at memorization. It's like builds all of its understanding of the world from pre-training data. It all happens in the lab, and then it builds memory in the form of its KV cache. But a transformer is not meaningfully learning at test time. All the learning happened in the lab, and like it's a good like thought experiment to think how useful transformer would be if OpenAI and Anthropic stopped training models today. If they said, okay, this is it. We are taking down training clusters. We have inference. We have this model and use it. And everyone knows that those models like they are limited. There are even those like ideas called freshness fine-tunes and knowledge cutoff, right? They need to keep retraining the model to make it up to date and have new skills and new capabilities. And this is what we want to make online, what we want to make happen at test time, so you don't need to do freshness fine-tunes. And I don't think like transformer just doesn't have the operation within its model that can do that. This is what we are searching for.
Got it. Do we have any general directions or the?
I
You have some ideas. Okay, cool.
Maybe we'll talk about it
next time. Yeah. Okay. Cool. Yeah. We actually have our team at AGI House like very big on like a neural-inspired different kind of architecture. Even I think I met Ben Spector, like the founder of Flappy Airplane. Like he was also tackling some of the data efficiency issues on the architecture. So while we're looking for the public announcement, maybe in the future, not distant future, we'll continue that conversation. Yeah.
Exactly.
So I think before we end it, we have a few other questions, maybe around. Let's see the. I think from the website of co-automation, I think one big part of the focus of co-automation is around the enterprise application. That part of things, right? How can you help elaborate that vision, like from that perspective?
Yeah. The vision is very simple, which is that everyone knows they want to have a model trained on your own data, but like training the model is currently like bad and weird. The fine-tuning process is not like very, very easy. And also the companies are worried about sending their own data out there to other companies. No one wants to do that. Sometimes they are held hostage because either you get a good model trained on your data and send your data or not. What do you do? And I think like the test time training is a very nice answer to that, because you get your own deployment of the model. No one else sees it. No one else has to touch it. You send your data to that model and to no one else. It can be on your own hardware, and then it improves on your data. It learns. It becomes genuinely your model because it learns about you and about your data. Like continual learning is solving the problem of personalization in a way how it should be solved. And I think like as every company, you need to try to imagine what product do you have, how do you eventually sell your research in some way. And this is how I think it really makes sense. And like current like there is a narrative, we need open weight models so that we fine-tune them ourselves, but I don't think anyone wants to be fine-tuning the models. In reality, you want to have continuous learning models.
I see. Cool. If co-automation the wildest success, what do you envision? What's it look like?
I imagine the world where we don't have to work. Like it does sound dystopian to some people, but I generally think it's where our future should be. Like work is nice, but at the same time, people still play chess, even though computers are very good at playing chess. People still run, even though the cars are faster than us. Like it is like it does feel a little bit more like a world without responsibility, but in some way, it is the world of superpowers. If the machines really can do for us all the work that we currently need to toil and sweat and like carry heavy things and think very deeply on something, if we can have it on tap whenever we want, however we want, like it is a much more like the world of agency in some way, how I think about it, whether we can dream of the things easily and they just happen in the real world because AI does it for us. And like a lot of new opportunities come from that, and how the world could be run, how our experiences could be, how our relationships could be. A lot of the things are very different. Sometimes I'm jokingly say, but it's not very much joke, that the future will look like high school. Because in many ways, high school is a world where no one yet has to work, no one has real responsibilities, and people just learn about things and spend time socially and try to figure out the world, and AI can always be this teacher teaching us about stuff and spending time with our friends, and I don't think it's that horrible.
Well, I guess that's very close to what do we call the AGI future. I guess. How would you think about the timer? I guess you're being like a very AGI pill at some point.
I'm AGI pill. Like, it definitely is coming. Like, I'm not joking when I say probably we have like few more years left of work at all. I don't think that the state of like us having to work and like is a thing that will last for a very long time. The question is like how the question is how quickly. Like, I have a tendency to be pretty optimistic about those things. But like, the reality is that the technology usually takes a while to deploy. The technology takes a while to percolate. Like, the AI progress feels both fast and slow at the same time. In some way, in 7 years, we made a huge progress on what our models can do. And in many ways, I already feel like living in the future. I am mostly vibe coding and mostly self-driving. Right now, but at the same time, still like our lives look like only a little bit different than they used to be in the past. But I think like, you know, I definitely think in the next 5 years, somewhere in there, like, probably the work will transform in a way that it's hard to like recognize it from the
amazing past. Future. Yeah, look forward to that future. That's what we are doing here. So I wish I have all the time to continue the conversation. We have another programming for you. So we will end up the talk for now. I look forward to welcome back at some other point where we see the model architecture progress. So I would love to tell you more Monday about what we are doing at Core Automation. Amazing. Yeah. So Jerry, the CEO of Core Automation, the man who taught a machine to think, and now teaching a lab to run itself. Find the team at coreautomation.com, I guess. So, and let's work together and see, help him to build the future that he's envisioning, and definitely want to be part of that. All right, thank you so much.